Hello guys, welcome back to In 5 Minutes. In this presentation we are going to see the maximum operating frequency for the asynchronous counter. Now we all know that the asynchronous counter work on the basis of next flip-flop is triggered by the previous one, then only the next flip-flop will work. Means what? If suppose we are considering a 3-bit ripple counter, the propagation delay for the first flip-flop gets added to that of the second, because unless and until the first flip-flop gives the output that is nothing but the propagation after the propagation delay of the first flip-flop, the second flip-flop could not work. And similarly, the second one takes time to transition to operate for the third flip-flop or the third stage. Means what? The third flip-flop have to wait for two propagation delays, one for flip-flop 1, another for flip-flop 2. So this propagation delay gets on added. So we have to calculate the total time period and depending on which the frequency. So first of all, here the total time period T is nothing but the propagation delay time of the flip-flop and the stroke pulse TS. Now we have to modify this total delay as T total will be equal to n flip-flop are used, so propagation delay TD, that is the delay time for each flip-flop, n times it will be multiplied and stroke plus is added. So hence the maximum frequency or the frequency operated should be less than or equal to 1 upon T total. Hence the F should be less than or equal to 1 upon n TD plus TS. Now here n is the number of flip-flops, TD is propagation delay of each flip-flop, and TS is nothing but the stroke pulse, width of the stroke pulse. Okay, so on the basis of that, let us see one problem in which we have asked that for a 4-bit asynchronous counter, the propagation delay for each flip-flop is 40 nanosecond. So in the solution given part, what I can write down is TD is given, so TD is equal to 40 nanosecond, width of stroke pulse TS 20 nanoseconds, and we have to calculate the F. So the solution is F is equal to, or F should be less than or equal to, so simply to find out the maximum clock frequency I have to put here equal to 1 upon n TD plus TS, and one more thing, n specified here is 4 since it is a 4-bit asynchronous counter. So the required frequency is 1 upon 4 into TD, that is nothing but 40 nanoseconds plus 20 into 10 nanoseconds. Okay, and if we calculate, it will be 5.56 megahertz, that is nothing but the maximum operating frequency for the asynchronous counter. If you are going to consider the synchronous counter, time delay is pretty much low. Why? Because all the flip-flops are triggered simultaneously. Then in that case, for the synchronous flip-flop, the T for synchronous, it will be equal to only time delay of a single flip-flop. Why? Because all the flip-flops are taking same time and they are all triggered at the same time, plus the TS stroke plus applied if any. So synchronous flip-flops, therefore for synchronous flip-flop, hence synchronous flip-flops or synchronous counters are more fast than the asynchronous, because in asynchronous the time delay multiplied by the n times, that is nothing but the number of bits or the number of flip-flop used to design the flip-flop or design the counter. So that's all about the maximum operating frequency of asynchronous counter calculations and why the synchronous counters are better than the asynchronous in the consideration of the speed of operation. And for more ideas, stay tuned to In 5 Minutes, and thank you for watching.